Good afternoon, ladies and gentlemen. Welcome to this presentation coming to you live from our studio in Karlsruhe, Germany. Thank you for joining on this very exciting day today. My name is Arnd Feye and I'm having the pleasure and honor of guiding you through some sessions this afternoon. In this session, I will talk about design changes and show you how easy it is to detect differences between two models and report the information graphically in 3D with a listing of all changes. We will have the possibility for Q&As. So if you have any questions, you're very welcome. Please put it to your chat at the right side of the window. And I will try to take as most as possible at the end of this session. You all know CAD data, and CAD data can be really complex. One of the challenges many companies are facing today is the management of engineering changes and model revisions. So comparing two CAD models is just about impossible for a person to do. And you will see now how easy it can be to compare two different CAD revision data. So we'll start with a brief introduction and a product update before I present to you three different use cases. First one about model-based definition and 3D master data. Second one about electrical harness assemblies, and the third one will be about drawings. So on the product update this year, 2020, we have 4 major releases this year so far, so there might be another one coming up by end of the year. So we concentrated this time and this year on the user experience. So we did several improvements on the 2D and 3D reports. We added additional information to the reports. There's also a new feature now available to arrange the report either again compared to the checks or versus the elements. Regarding the 3D HTML report, and you will see this in a few minutes live, the 3D model data can now also be stored of the compare model. You will see what this means. And we also did some better improvement and highlighting of small differences on drawings. So if you have really small areas on a whole sheet or view that have been changed, we are indicating these areas now much more better. Also, what comes into the user experience is especially working with FDNA models, that you will only highlight and see the selected component. So about functionality, our enhancements are of course much driven by our customers and by your input. So we did a lot of improvements in the electrical domain and also for the annotations. We added support of VPM V4 and V5 and also came up with a color representation and visualization of changes. IT side and from the administration perspective, you can add now multiple config paths to also allow users to create only profiles, and there's a higher flexibility of defining the checks themselves. So everything we do is really in close collaboration with our customers in a very agile development process, and we try always to provide a very fast delivery when you ask us to do any improvements. So coming to the first scenario, and this is about model-based definition in 3D master. The industry is becoming more and more reliant on 3D data for collaboration and manufacturing. Beside the geometry itself, model-based definition models must contain information such as geometric dimensions, tolerances, nodes, finish symbols, material specifications, and all other non-graphic information that typically reside on manufacturing drawings. So it's very essential that these data being shared are based on common modeling standards. And most important, it must also be accurate, of course. And another challenge you have is that the users must apply these rules in a daily basis in a very simple way. Comparing 3D model geometry, PMIs, and attributes can really be frustrating for the users and very exhausting when you have to do it in a daily way on complex models. And you will see in the next 3 scenarios how simple, quick, and easy it is to create these comparisons and also to share these results through HTML or 3D HTML reports. Users of these reports will not require to install anything. They can simply use their browser and view the results and the change report. Let's have a look how this works on a data, including model-based definition information. We start the xCompare. Several checks are performed. And let's start at the beginning now, looking at the geometry, at the shape differences. Here we see the model. There are certain changes in the color map visualization. So green and blue are areas where you have less material differences. Or you can do it in a wireframe mode, where black lines and curves and edges are showing you identical curves, and red and green are the modifications. So if you want to drill down more deeply, you can also use the feature check, which indicates you the particular features that have been modified based on this whole example. Or with sketches. So on Sketch, and we use the enhanced visualization function of xCompare now, you can imagine and see hopefully on this image that there were indicated 2 different sketches what has been modified. Coming to dimensions, we now have both models side by side, and you see very easily from left to right, there's a locked view when rotating and zooming it, where the differences are, like this diameter from 170 to 171. Similar with tolerances side by side, but also here you can use this enhanced visualization option to overlay the information from, in this case, the right model to the left. Closing xCompare, optionally you can store the information of the geometry differences as a xCompare representation feature. And this gives you now the ability to share the model in a very easy way, also with colleagues, indicating the differences. Having a look at the 3D HTML report as a result, you just need a browser and it comes with the viewer and all information inside. So you have the 3D data in a tessellated format. Again, here the differences of the geometry, but also you can navigate through the tree now and highlight and investigate the differences on the dimensions. So that example was showing you how easy it can be really to modify and to identify the differences of 2 models. The next example that I have prepared for you is about the comparison of an electrical harness. During this year, we have extended the functionality together with a very valuable input from our customer Volvo Cars. And here, big thank you to Volvo Cars for allowing us to use this sample model for this demonstration. A challenge when comparing electrical models is not only to identify the different laying of the cables or the lengths, but also of course, diameters of bundle segments, but also detecting different connection points, supports, or protections that are equally important to any differences in the shapes. Here let's have a look at this result. Again, we start xCompare here from with both models loaded. The calculation is done, and we start in this case with finding differences on removed or added elements. So on the left side, we see the clip or this cable tie is there on the left side. On the right side, it's missing, so therefore it's indicated here by xCompare. In this case, we have this clip here, but it's in a different location. So with the enhanced visualization, we can shift this information to the left model in this case. Again, here we see the different layings of the cable, where the cable itself has been modified. Similar to what we saw just before the parts, we can also here use the wireframe mode to illustrate these differences. Again, here black is identical, green and blue in this case was different. Looking more in detail into electrical checks of this bundle segment, we see that there's a difference of the lengths also indicated here in the results, because these information are taken from the feature input, from the properties of this bundle segment. As a result, also in assembly, we create a 3D HTML, and we have all the navigation functions available in the 3D HTML report as well. So the viewer is inbuilt, and you can navigate through the differences. The model itself is rotated in the right direction, zoomed in the right direction. We have the text information and also some screenshots on the side. So here for the electrical models, you see very intuitive, very easy to use and to identify the differences. The last example I have for you is for drawings. So in drawing-based organizations, engineering changes are mostly documented within the drawings, but you have no graphical validation of the real presentation of this change. So the report typically summarizes what is available versus what was available in the text. So you typically have just a text field where the user documents these changes, and also indicates the zone on the viewing where the changes happened. This process is very manually, it's very time consuming and relies a lot on the change and on the notice of the documenter to ensure that the information is accurate and complete. And if you now look back from the consumer side, so however the consumer is restricted to interpret these results that was documented, and there's a high risk of a misunderstanding to really not catch what was written by somebody else. This is also a problem because there's typically a reduced or limited space for the text to input on the drawings themselves. And knowing about this and having these challenges, organizations and companies can suffer from a major loss of information and efficiency by manually reviewing this information and recording these changes. Yeah, and this is also where xCompare provides you in a very automated way change reports. So what we'll see in the next scenario of the drawing is again the manual process, but of course, all what we just saw is available in batch mode as well. So you can integrate xCompare in automated processes, trigger a batch of xCompare with the input of the two revisions, apply a configuration where you decide what is important to you, what kind of differences you really are interested in, and what is less important. xCompare offers you a big suite of checks, and this is where you once decide what is important to you, like we just saw the electrical model, new features, deleted features, so a changed BOM of the assembly is for sure important. Also, translation of parts and movements of parts will be certainly a topic for you. But probably you're less interested in a color change of a part. So then you simply just not take this check in xCompare and assemble your kind of a check profile in xCompare. Don't worry, it's if you know QCheck, it's much less work to do, and of course we are supporting you with our knowledge and best practices. Also, xCompare comes along with a standard, common use set of a configuration. Yeah, let's have a look at this drawing now. So we start directly in the drawing itself. We see some differences on elements. Again, here, new and deleted. Just one example, there's one difference. Again, differences in diameters here, where dimensions have been changed, represented visually, but also the text output is there if you want to use it somehow in the process later on. Yeah, roughness symbols, everything like this is displayed. Here an example. Let me try to stop this video for a second. We see a quite long text node with a lot of information, and of course it's very hard for the user to identify difference, because you would really read through everything to detect the difference. Here the overlay mode again, and I hope you can see it in the first line, that the first line has been modified. So with green and red text, there's a difference displayed here in the overlay mode. We'll see shortly on the report that it's even better highlighted in the report itself. So let's go on. So we have a difference here. And finally, there's also an ability for you to compare the whole sheet or several views in an overlay mode, and the result will be a high resolution image. So again, here we have an overlay of these, this view in this case, black, everything is identical, and with green and red in this case, so the color can be adjusted in the configuration, you see highlighted the differences. So this also works for views that are moved on the whole sheet. So if you have front view and everything is organized differently on the new revision of the sheet, this will be repositioned automatically by xCompare, and you have a very proper overview of the views and the differences. So let's go through some of these details. Here again, it's even better to see differences in these detailed views. So let's create an HTML, and this is now, we call it a 2D HTML, listing all the differences, starting with, in this case, modified dimensions. Again, here I stop this video for a second. We see the first line, there is a must, assembly must be. And if we go to the other one, there it is named assembly has to be. So a small text change, but highlighted very clear in this report. So when having these images and seeing these images, you see they are high resolution images. If you click on it, you can really zoom into it, and this works very well even in very large drawings and views. Yeah, coming to the end, I'm ending this presentation with just a summary. xCompare dramatically reduces the efforts and cost for creating change reports. Yeah, furthermore, there's a risk of course, overseeing changes, and this can be handled by xCompare much more better. So there's a lower project risk when using a tool helping you to create these changes and identifying the changes. Yeah, having said this, any expensive downstream consequence can be avoided if model changes are recognized fast and instantly when they happen. And finally, the xCompare also increases the satisfaction of the engineers by lowering the risk of making errors and not documenting changes properly. But they will also be happy because creating change reports will now be fun and not really a major task of the work to do. Yeah, and on the other end, also the end users and the consumers of these reports can be much more happy because reusing these reports is very easy, very simple. You saw with the HTML reports, and they can also rely much better on the output because the tool for sure has not overseen any difference. So thank you very much for joining this session, and I will now try to look if we have any questions. Let's see. There's a question coming from Franz about electrical in JT. Yeah, thank you, Franz. Yeah, there is an xCompare product as well available in JT in our Light 3D portfolio, but there are no dedicated checks today on the electrical design. Okay, Herbert just commented on this. Yeah, then thank you very much for joining this session, and we are continuing with the Carver user community in a minute. Thank you very much.